This session explores what quantitative data really is and why it sits at the heart of statistical analysis and business decision-making. We will walk through how numbers move from a raw, messy list to clear patterns using frequency and cumulative frequency distributions. You will see how simple tables and intervals help you interpret what is happening in your sample. Along the way, we will connect these ideas to business meaning, not just mathematical mechanics. By the end, you should feel more confident about quantitative data, reading these tables, and using them to support decisions. Quantitative data is any data that deals only with numbers, whether that is a count or a measured amount. If age is the variable, calling one person 8 and another person 4 is not simply a label, it tells you the 8-year-old is twice the age of the 4-year-old. Some quantitative data is discrete, like number of children in a household, where the values are whole numbers. Other quantitative data is continuous, like income or time, where decimal values and all real numbers are possible. Because differences and ratios are meaningful here, this data type is powerful for comparing performance, sizing opportunities, and evaluating trends. In business, we often start with a question or hypothesis, such as whether a new policy reduces hours spent on a task or changes customer behavior. Quantitative data allows us to test such hypotheses using actual counts or measurements, rather than impressions or assumptions. Because we can see differences between data values and represent them as proportions, we can ask questions like, how much more, or what share of the represented population? These numeric comparisons set the stage for more advanced measures of central tendency and variation later. Even before those more technical tools, simply organizing the data helps us see if our initial ideas are supported or challenged. In the real world, data often shows up as long lists of values, sometimes thousands of rows and columns deep. Staring at that raw content rarely tells a helpful story. A frequency distribution table gives us a compact view by listing each data value and how many times it occurs in the sample. If a value appears 6 times, the frequency attached to that value is 6. When you add all the frequencies in the table, you get the total number of observations in your sample, such as 20 tasks listed in the example shown here. This simple structure turns a confusing list into an organized snapshot of how the data is spread out. This example presents the number of hours taken to complete each task for 20 tasks, and the values range from 0 to 5 hours. To create an ungrouped frequency distribution, you list each possible value of hours, 0 through 5, then count how many tasks match each one. For instance, there are 4 tasks at 0 hours, 6 at 1 hour, and so on, all of which sum to the full sample of 20 tasks. With that single table, you can quickly answer questions like how common it is for tasks to take very little time, or which time duration is most typical in this sample. This straightforward interpretation is often more valuable in a business setting than complex formulas. It is quite obvious here that there are 3 tasks that take more than 5 hours each to complete. This should trigger a review to determine whether those tasks are qualitatively different enough to justify the higher time usage, or if there is an underlying cause that needs to be investigated. Cumulative frequency goes one step further by adding up all frequencies up to a specific data value. Instead of asking, how many tasks take 1 hour to complete, we asked, how many tasks take 1 hour or less? In the tasks data, the cumulative frequency at 1 hour includes the 6 tasks at 1 hour plus the 4 at 0 hours for a total of 10. This process continues down the table so that the final cumulative frequency at 5 hours equals all 20 tasks. To do this correctly, the hour values in the table must be listed in increasing order so the accumulation makes sense. In this table, 11 tasks take 2 hours or less to complete out of a total of 20 tasks. If the goal was to shorten task time, it is the 9 tasks that take over 2 hours each that need to be addressed first. Frequency tables give you a clear view of how to set priorities for time, customers, or units based on a particular threshold. When the variable of interest can take on many possible values, listing every single one in a table is not helpful. Household income is a good example, with countless possible amounts. Grouped frequency distributions handle this by creating intervals such as less than 50K or 50K to 100K, and then counting how many observations fall into each band. These groups help you see how your population or sample is spread across meaningful ranges, even when the underlying data is very detailed. It is important that each interval has its own clear lower and upper limit, so that each data point falls into one and only one group. This approach makes discussions around markets or segments much more practical. In the task case, we can move from single values to broader class intervals, such as 0 to 1 hours, 2 to 3 hours, and 4 to 5 hours. Because the data is discrete and only includes whole hours, there are no observations between 1 and 2, or between 3 and 4, so the intervals are sometimes called interrupted. If you were doing highly precise manual work, you might adjust each boundary by 0.5 hours to create continuous intervals, but for business purposes, the simpler groups are usually enough. This grouped view lets you talk about tasks taking low, moderate, or high amounts of completion time without losing the connection to the underlying counts. It mirrors how leaders often think about categories of task efficiency, customer engagement, or workload. One thing to watch out for is that grouping without clear goals can often oversimplify important details. In our example, 17 tasks take 2 to 3 hours completion time, but there are no tasks that take 4 hours. Grouping 4 and 5 together could potentially hide what makes the remaining 3 tasks more time-consuming than others. Building on the same task time frequencies, we can convert raw counts into relative frequencies by looking at the share of the sample each value represents. Instead of saying 6 tasks take 1 hour each, you focus on 6 out of 20, which can be expressed as a proportion. This view aligns with business questions like, what proportion of our customers behave this way? Cumulative relative frequency extends the idea to show the share of the sample at or below each value, giving a sense of how quickly the distribution accumulates. Software and AI tools can automate these calculations, but the real value lies in how they help you interpret the shape of behavior in your sample. In the example, 85% of the tasks take 3 hours or less to complete, which implies that for improving efficiencies, the top 15% of the tasks should be investigated first. More importantly, the 4 tasks at 0 hours reflect 20% of all tasks. Identifying what results in that speed could help inform policies for the general business tasks. Across these examples, the pattern is that organized data tells a much clearer story than a raw set of numbers. Frequency and cumulative frequency tables help you see what is typical, what is rare, and how your sample builds up across different values. Grouped distributions then allow you to talk about ranges or segments that match how leaders think and decide. As you work with your own data, focus on structures that make the meaning obvious, not on unnecessary calculation detail. And once you see the structures, apply critical thinking methods to compare performances across different groups before launching into more testing or making policy changes. When you do that, your quantitative data becomes a practical guide for informed, confident decisions.